So in this podcast, we're taking two half reactions and combining them to make a new reaction. Alright? So if you saw this podcast, here's how we took an equation and broke it into its two half reactions. Alright? Now what we're going to do is we're going to combine two half reactions into a balanced chemical equation. Alright? So, let's kind of let's identify which half reaction is which. Alright? So in this particular one, we have electrons that are being added to a species. We're just calling it a species, whether it's an element or an ion. So this chlorine is gaining these. So gaining electrons reduced. So this is our reduction half reaction. By default, we don't even have to check it, we'll confirm it. This has to be our oxidation half reaction. So does that make sense? Well, Leo, lose electrons oxidized. So over here we have electrons. So bromine had some electrons, and bromide had some electrons, and now it has lost those electrons, okay? Because they're a part of the product side. So we have a reduction half reaction, we have a oxidation half reaction. What you have to do for these is find the least common multiple of electrons. Okay? So in our oxidation reaction, we have 2 electrons, and in our reduction reaction, we have 2 electrons. So that is done for us. So all we're going to do is simply combine these two reactions. We're going to write everything that's on the reactant side on the left side, and everything on the product side on the product side. So we're going to write Cl2 plus 2 electrons plus 2 Br minus 1. And then an arrow. And now I'm going to put everything on the product side. So we have 2 Cl minus 1 plus Br2 plus 2 electrons. Alright? What happens is, because we found the least common multiple of our electrons, we should have the same number of electrons on both sides, and that's going to end up being erased. So I grab my eraser. That's gone. That's gone. And notice, once we've erased everything, everything should be balanced, just like we balanced an equation first semester. Let's say that's really a plus sign right there. So we have 2 chlorines, we have 2 chlorines. We have 2 bromines, we have 2 bromines. We have 2 times the -1 charge, so we have a total charge of -2 on the left. We have 2 times -1, we have a total of -2 on the right. So everything is balanced. So just in our next one, let's say we have 2 electrons over here, so this nickel lost them. So this is our oxidation half reaction, which means by default this has to be our reduction. Is it showing gaining electrons? It is. We have 2 electrons over here, but we only have 1 this time. So our least common multiple is not done for us already. So what we need to do is we need to multiply this half reaction by 2. Alright? So we end up having 2 electrons. So again, I'm going to do that in one step and combine everything. So we have nickel plus, notice we're really multiplying our silver by 2. So we have 2 Ag plus 1s plus 2 electrons. Or these 2 electrons is this 2 times my electrons right here. And that's going to yield, so I'm going to go back over here and grab my products, nickel 2 plus plus 2 electrons. And then I can grab my silver here, but I remember I have to multiply it by 2. So plus 2 Ags. And again, I should have the same number of electrons on both sides. I do. So I'm going to erase that. And what do I have left? I have 1 nickel. I have 1 nickel. I have 2 Ags. I have 2 Ags. Over here I have 2 plus 1 charges. So that's a plus 2 charge. And over here I have 1 plus 2 charge. So this is a plus 2 charge as well. So again, when we balance equations in redox, we have to balance our elements and our charge. Alright? But if we have half reactions, it basically does this for you. Our very last one, we have electrons down here on the chromium side that are being lost. So that is our oxidation reaction, which means over here with lead, it's gaining electrons, so it's being reduced. And then if we look at least common multiple, we have 3 electrons and 2 electrons. So our least common multiple is 6. So with this equation, we need to multiply it by 2. And over here with this equation, we're going to multiply it by 3. So when I combine these, I really have 2 chromium metals. I'm going to add that to 3 lead ions. And 6 electrons. And that's going to yield, go back to my chromium side, 2 chromium ions. And I have 2 times 3 electrons against, that's 6 electrons, plus 3 leads. Alright, so again I have 2 electrons on both sides, so I'm going to get rid of those. And we're going to see if everything is balanced. So I have 2 chromiums on the left, I have 2 chromiums on the right. I have 3 leads on the left, I have 3 leads on the right. I have 3 lead that have a +2 charge, so overall that's a +6. And I have 2 chromiums which each have a +3, so that is +6. So everything is balanced, and that is essentially combining half reactions to get an overall balanced equation.